This is TWiT.
Let us now join. Let us now get with Mr. Sam Abuelsamid. He is a principal researcher at Guidehouse Insights. He is our car guy, the host of the Wheel Bearings podcast, and joins us from beautiful Ypsilanti, Michigan, which today looks like the bridge of the Starship Enterprise.
Wow, that looks cool.
Hello
hey,
there,
gentlemen.
Sam.
How are you today?
Doing well.
Great. How are you?
Good to see you too.
So, I'm the Celestique. Isn't that a Cadillac brand?
It is a Cadillac, and it's pronounced Celestic.
Celestic.
Not Celestique.
Yes.
Nope. Like
When you
lyric,
spell it with an IQ.
Optic
IQ spelled with a C.
Actually, it's
No,
spelled with a
Q.
slash Q. So
the Cadillac Optic is spelled with a Q.
It's an optique.
no,
No. IQ is the designation that Cadillac is putting.
I get
in
it. It's
their
IQ.
model names
It's
for their electric vehicles.
Okay, because it's smart. I get it. Okay.
Yes.
So I have been saying
lyric,
Celestique,
Celestic, Optic.
Now I understand why people were laughing behind their hands.
what is that behind you?
You know what though? A lot of people say that.
Yeah.
So a few days ago, I paid a visit to Warren, Michigan, to GM's Tech Center. And down in the basement of the Sloan Engineering Building, they have a new lab that they started building last September. It is their software quality lab. And given how long, GM and other automakers have been doing software, you would think that, software quality lab would not be a new thing, but it is. GM, like most automakers, as we've been making this transition over the last few years to what they call software-defined vehicles, the complexity of software in vehicles has just exploded compared to where it was 25 years ago when I was doing automotive software for things like traction control and stability control and brake-by-wire. It has just gotten way more complicated. And the legacy automakers like GM and Ford and Volkswagen and Volvo, as they've been trying to do this, they've been struggling with how to test this stuff, how to set up their organizations to be able to develop software. Because up until 10 years ago, when Tesla launched the Model S, software was something that went into a vehicle when it was built, and then it was never changed over the life of that vehicle. The software in a vehicle, it was static. So when a new program would launch, go into production, there would be a deadline, usually a month to 2 months before job one, when everybody doing various software bits for that car, it's pencils down, it's finished. It has to be done by that date. And then there was generally no updates to a vehicle once it was in production. But that has all changed. Tesla starting with the Model S created this idea of, we can push software updates to vehicles over the air, and we can add new functionality to vehicles years after they've been on the road. And so that means the software has to be set up in a totally different way. And the processes for producing that software have to be set up in a totally different way. And that's something that legacy automakers, making that transition in their organizations and their processes, has had to change. And I don't know if you recall back in December when after GM launched the Chevy Blazer EV, in December, they actually had to put a stop sale on that vehicle, and they didn't resume sales of it until about March of this year because there were so many software problems with it.
That's not good.
Yeah. So this new software quality lab is designed to try to make sure that doesn't happen again.
Why is it so hard? I mean, the computers have software. Why is it so hard? Is it the automakers don't have the skill set? No, they can hire good coders.
It's the nature of the kind of software and the way that it's being deployed. So when I was doing automotive software, the software was deeply embedded. It was tied very close to the hardware. So we were using relatively low power microcontrollers, and the software that we wrote was very specific to that hardware. And so you couldn't just go from, a TI chip or an NXP chip or an Intel chip and switch it around you'd have to basically completely rewrite the software. A lot of it, when I started, we were writing Intel assembly code. And so the code was designed to never be changed. Now, you've got, and all of the different functions in the car were basically siloed from each other. They didn't interact very much. Now you've got all these features that are software driven, and there's a lot of interaction. And we're now deploying an architecture, where there's an abstraction layer. It's a lot like the way Android and iOS work, in that there's an application layer. So you got applications on the top. Those applications don't ever actually talk directly to the hardware. They talk to APIs. So there's this layer that separates the hardware from the applications. And so you call APIs if you want some data, and you call APIs when you want to send a signal to, if you want to tell the brakes to apply. You call an API to do that, just like you would call an API to send, to take a picture, to tell the imaging sensor to take a picture. Mm-hmm. You don't actually call the imaging sensor, you call an API to do that. And they're doing the same thing in cars now, so that they can be able to make changes in the hardware and the software asynchronously. So we're shifting to a model that's much more like the traditional tech industry, but unlike the tech industry, where safety wasn't really a concern, because if the applications on your phone crash, people don't usually die very often. When an application crashes in your car, people can die. Mm-hmm. So you've got these two different mindsets of safety first and move fast and break things, kind of battling each other. And so it's finding a balance in there and trying to get the best of both of those worlds in there. So what's cool about this new software lab is they have developed these new test benches. They've always had, test benches where, for things like the infotainment system, basically they would, in the old days, like 10 years ago, they would just have a rack that had your infotainment display, your center infotainment display, and some switches and buttons. And engineers would sit there and they would test, load software onto it, and they would test stuff. And it was all done in person. And, it was comparatively simple compared to what we have today. Now we have these giant screens, usually multiple screens in the car. There's much more that's being controlled by the software. And so these new test benches have there's versions of this for every vehicle configuration they have. The one behind me here on the screen is for the new Cadillac Celestiq, but there's versions for the Chevy Silverado and the GMC Sierra and every other vehicle GM makes. They've got 300 of these now, and they're adding more all the time. And in addition to having all the screens, all the switches, there's also the radios and all of the ECUs, not just the infotainment unit, but all the ECUs in the vehicle, all the electronic control units. And the engineers can be sitting there at the bench testing stuff, loading software on and testing it. But these are all networked together as well, so they can run it remotely. So if they're working remotely, or for example, if an engineer in Israel, a developer in Israel, or a developer in China or India wants to run tests on a bench in Warren, Michigan, they can do that. They can log in and run their tests. And then when they're not being used by an individual, they can also run automated testing, and they're using Gen AI to run, to create all the different scenarios, all the different possible combinations and permutations of the way the controls could be manipulated in the vehicle, the signals that could be coming in to test all this stuff. So they're doing a lot more testing, and they're tracking, they're monitoring the utilization. As they get up to about 70% utilization on all the test benches, then they start adding more. So they right now, they said they've got about 300 of these in Warren. They've also they've sent some to Google because GM uses the Android Automotive OS for their infotainment. So Google's got some that they use for testing their stuff. They've they're also going to be sending some to Israel and India and to China, where they're testing different operating systems. So hopefully this will lead to some improvement. One of the other interesting things is in this lab, they actually have femtocells for AT&T and Verizon. And each one of these test benches has the antennas that they have on the car, the cellular antennas that they have on the car, so that they can test over-the-air updates. So they can push over-the-air updates to the test benches and make sure that those are going to work properly.
Very cool. I'm glad that they're paying attention to software. You said you wrote an assembly language, Intel assembly language. What are they doing it now in C++?
They use a variety of different languages. Some of it is in C and C++. They use I think Rust for some things.
Oh, good. Rust is a nice language. Yeah.
Yeah. They depending on what the applications are, they're written in a variety of different languages. Obviously, the Android applications that are running on the infotainment system,
Java,
those are being written in Java or Kotlin.
Yeah, right.
So there's a wide range of things that they use.
So
and all of it has to work together. All of it has to interoperate.
It's interesting. I think more and more car companies, for a long time, QNX, which is owned by BlackBerry now, was the real-time operating system choice of car
and they still use QNX in these too for some parts of the system.
QNX and Android Auto.
Yeah, there's multiple operating systems that are running some. This is part of why it's so complicated.
No kidding.
Because with the latest generation of GM's software platform, I talked about that abstraction layer where you're abstracting the hardware away from the software. The lowest level of that stack is actually running Red Hat Linux.
Good.
And then you're running this abstraction layer, and then you're running things like QNX and Android Automotive, and in some cases, I don't think GM's using automotive grade Linux, but some manufacturers use automotive grade Linux. Some it's just other flavors of Linux. So there's a variety of different things that are running in containers on top of this. That's part of this middleware layer. And so that's part of what adds to all this complexity.
And then is one of the reasons they have multiple operating systems to separate the telematics from the entertainment system? Because for security, you don't want one operating system that can do everything.
Well, there's also that some portions of the controls, like for example, the instrument cluster. That stuff has to be real-time control.
Right.
So you can't use like Android to run your diagnostic alert lamps and your speedometer and things like that. That has to be a real-time control system. So that's where they're using QNX to run pieces like that. And then using Android for the infotainment and using other things for the driver assist system. So
it's complicated, isn't it?
Yeah, it's finding the right tools for the job.
I think Tesla is much simpler, isn't it?
No. They're they also run multiple different systems in their stack as well.
Okay.
Everybody does.
That was the thing that, at least I thought, distinguished Tesla, is that they had a more of a Silicon Valley approach to cars.
It's still a multi-layer stack.
Yeah.
The thing that Tesla did that was really unique first was starting to consolidate down the number of ECUs. So starting when we started putting electronics and software into cars in the 1970s. So software in cars, not a new phenomenon. We've been doing this for almost 50 years. Yeah, since the 1970s.
What was it in the 70s that it was operating?
It started off with
fuel injection.
Well, even before fuel injection, just some of the basic engine management system, and then transmissions, and ABS came along in 1978.
ABS, sure.
And the thing is, over time, there was this very piecemeal approach to adding electronics and software to vehicles. The way the supply chain worked. Automakers, if they wanted to add a new feature to a car, they would go to a supplier and they would buy, I'll use ABS as an example because that's something I worked on, but it applies to all kinds of things like, climate control systems, dual multi-zone climate control, and those fancy sequential tail lamps or turn signals that you have on modern cars. All of these things, you buy a feature, and that feature would include a set of sensors, a set of actuators, and an electronic control unit with some embedded software. And so you'd have to distribute all these ECUs around the vehicle for all these different functions.
Oh, wow.
And they were on a network, on a CAN network, a controller area network, but it was a fairly slow network. They could share some data, but they didn't really interact very much. And so modern cars, you might have as many as 100 to 125 ECUs around the vehicle.
Wow.
For each discrete electronics and software, but they have to communicate with each other.
It's a Frankenstein.
Crazy.
Yeah. And what Tesla did was they started to consolidate these and bring put applications together in single ECUs. And that's what GM and other companies are doing now. And the next generation of what we call EE architectures, electrical and electronic architectures, are getting down, to under 10 ECUs.
Oh, that's much better.
And so you
look at the wiring harness on some of these cars. They got this complicated system.
So does that mean though that before, if your ABS wasn't working and it turned out that it was just the brake light switch that the car no longer had access to, you could just replace the brake light switch. But now if you have fewer ECUs, when something goes wrong, is it harder to fix? Is it more how does it impact?
It can be harder to fix because you have to figure out, okay, is it a software problem? Is it a hardware problem? Where is the hardware? And this is one of the reasons why automotive software is so complex, because a lot of it is diagnostics, diagnostic code. So especially for anything safety critical, there has to be diagnostics for all of the things that could potentially go wrong. And so, when I was doing this stuff, we spent a lot of time just developing the diagnostics algorithms to determine, has the brake switch failed? Is a wheel speed sensor bad? Is an accelerometer bad? All of these things that could potentially go wrong. And, because of the complexity, it's not easy for a service technician to just, replace a part. They have to figure out, what do we have to replace? And so you need that combination of the software and the hardware working together to be able to service these things. So it's and it's funny. About 3 weeks ago, I visited the Rivian Tech Center here in Michigan, and Rivian just recently rolled out an update to the R1T and R1S, their first two vehicles, and they transitioned to a new EE architecture. Previously, they had 17 main electronic control units. They now have 5.
Wow.
And as part of this revamped architecture, they eliminated 1.6 miles of wiring.
Are you kidding? That's amazing.
A typical modern car that has a traditional EE architecture might have 3 to 3.5 miles of wiring in the car.
My goodness.
It weighs several hundred pounds. And Rivian eliminated 46 pounds of copper wiring, 1.6 miles of wire in this new system.
Amazing.
Yeah.
Amazing.
I love having you on the show. I always learn something so interesting every time you're here. I appreciate it.
Mr. Sam Abuelsamid, principal researcher at Guidehouse Insights. And of course, if you love cars, you'll love Robbie, Nicole, and Sam talking about cars on Wheel Bearings, their podcast.
And there's a fresh episode up now. We recorded it this morning. I just published it about an hour ago.
Nice. Wheelbearings.media. Thank you, Sam. Have a great day.
Thank you. And hopefully I'll see you in the next couple of weeks. I'm going to be out in your neck of the woods for vacation in Sonoma.
Vacation? You're not driving somebody's vehicle?
No,
You're actually
just going to, well, I'm driving somebody's vehicle that we're going to use while we're out there. But I'll be out there the last week of July for just relaxing.
You should come visit us because we think that maybe the last week of the studio. In fact,
I will try to stop by.
Do you think you could be here on, what is the last Sunday in July? Because I think that's the Sunday that Alex Lindsay wants to do a 3D version of TWiT suitable for use on Vision Pros. And we want to have all live in studio guests.
Yeah, I'm trying to make it an actual vacation.
Oh, well, excuse me.
I don't want to
tell your wife you'll be in 3D, my friend. This is an opportunity.
She sees me in 3D every day.
That's right. Okay. Well, no, I think I
will try to stop by.
Yeah, say hi anyway. We'll take you to dinner. All right. Thanks, Sam.
Bye, Sam.
Take care. Wow. Hey. Hey, if you like what you just saw,
all you got to do is head to twit.tv/ATG to subscribe.
then smash the bell, hit the button, and I don't know, do that stuff the YouTubers do.